Contact pressure distribution. Contact pressure distribution is defined as the vertical pressure acting at the surface of the contact between the base of the footing and underlying soil. Suppose this is my foundation. This is the base of the footing, and the load is being applied. Due to this application of load, pressure will be exerted in this area, base of the footing. To resist this, there will be a force acting from the underlying soil. Yes. So what it basically means, because of this load, there will be consolidation occurring, and we know that there is primary consolidation, secondary consolidation, and elastic consolidation. But we're here to discuss about this contact pressure distribution. So basically, contact pressure distribution means this due to this load, to resist this, there will be a force acting. This would be my contact pressure in between this base of the in between the base of the footing and the underlying. This is my contact pressure distribution, and the contact pressure distribution depends on first one is stiffness of footing, stiffness of the soil, and third one is types of loading. So now we will see that this how the contact pressure act in a rigid footing and in a flexible footing. This is for flexible footing, and this is for my RIGID rigid footing. I'm just drawing it down without saying anything, because sometimes you look prettier when you stay silent. Silence. Q is applied, and this is my footing. And now we will see that the effect of this contact pressure, how does it act on the flexible footing and in the rigid footing. So first of all, you need to note down only two points that would help you to draw the diagram or have the understanding of the diagram. First one we have for flexible footing, contact pressure is uniform, and the second one is settlement will vary according to length. And for the rigid footing, it's like vice versa of this flexible footing. First is settlement is uniform, contact pressure vary according to length. This is the diagram. This is the load. This is here it says level. Contact pressure is uniform. So this is contact pressure is uniform. And now here again we will have cases for clay and sand. It's for like first we'll have for clay, and then here for sand, fly soil, or sand is for coarse soil. First for clay, in case of clay, P or Q, it's depend on you. Settlement is uniform. Okay. Contact pressure. This is my contact pressure. Contact pressure is uniform, and this is for the settlement, and this is for my contact pressure. This is my settlement. This is my CP. In the case of clay soil, the settlement is maximum at the center and minimum at the corner or edge, and the contact pressure is uniform throughout the settlement. And for sandy soil, or coarse soil, this is my settlement, and this would be my contact pressure, CP. Here you can observe that the settlement is uniform. Settlement is uniform in the case of coarse soil, but contact pressure is minimum at the center and maximum at the edge. Here it was uniformly varying, but here. Now for rigid footing, here it says that settlement is uniform. This is my very initial when the settlement occurs. And also we have for like clay and sand. In case of clay, we'll see that settlement is uniform, but contact pressure is maximum at the center and the minimum at the edge. Similarly for the case cohesion lace, we'll observe that settlement is uniform, but the contact pressure is maximum at the edge and minimum at the center. This is the only thing that you need to remember. But in the examination, what they will ask basically is, in the case they may ask for the case of the clay or sand, the pressure, how the pressure is distributing. It is the settlement or contact pressure. Again for the sandy settlement or contact pressure. But you can remember it in a simply is your own terms. Like if you remember this formula, then it's going to be like here. It is going to be the opposite, like not opposite, but you can relate it by seeing the picture. And once you relate this picture to each other, you can see that here it's almost like the same. For the summary, contact pressure in the case of clay, this flexible pavement, contact pressure is uniform. Contact pressure is uniform, and the settlement will vary according to the length. Here, the settlement is maximum at the center and minimum at the edge. But for the case of sand, the settlement is uniform, but also the contact pressure is minimum at the center and the maximum at the edge. And for the rigid footing, the settlement is uniform. The contact pressure will vary according to the length. Settlement is uniform, and the contact pressure is varying, maximum at the center and the minimum at the edge. And for the case of sand, minimum at the center and the maximum at edge. Thank you. And in case if you like, I've shared my notes. You can see it for the reference. Thank you.